Hello everyone, I Sania, Faculty of BCA Department from Tecnia Institute of Advanced Studies. Today I am going to represent a lecture on modes of data transfer. Let's start now. Transfer of data is required between CPU and peripherals or memory or sometimes between any two devices or units of your computer system. To transfer a data from one unit to another, one should be sure that both units have proper connection and at the time of data transfer, the receiving unit is not busy. The data transfer with the computer is internal operation. All the internal operation in a digital system are synchronized by means of clock pulses supplied by a common clock pulse generator. The data transfer can be synchronized or asynchronous. When both the transmitter and the receiving unit use same clock pulses, then such a data transfer is called synchronous process. On the other hand, if there is not concept of clock pulses and the sender operators at different moment than the receiver, then such a data transfer is called asynchronous data transfer. The data transfer can be handled by various modes. Some of the modes use CPU as an intermediate path, other transfer the data directly to and from the memory unit, and this can be handled by in three following ways. First is programmed input output, second is interrupt initiate input output, and third is direct memory access. Let's explore one by one. First is programmed input output mode. In this mode of data transfer, the operations are the result in input output instruction, which is a part of computer program. In this mode of data transfer, the operations are the result in input output instructions, which is a part of computer program. Each data transfer is initiated by a instruction in the program. Normally, the transfer is from a CPU register to peripheral devices or vice versa. Once the data is initiated, the CPU starts monitoring the interface to see when next transfer can made. The instruction of the program keep close tabs on everything that take place in the interface unit and the input output devices, like shown in this diagram. The transfer of data requires three instructions. First is read the status register. Second one is check the status of the flag bit and branches to step 1 if not set or to step 3 if set. Next is read the data register. In this technique, CPU is responsible for executing data from the memory for output and storing data in memory for executing of the programmed input output, like shown in this diagram. This is the flowchart of input output programmed. The main drawback of program initiate input output was that the CPU has to monitor the units all the times when the program is executed. Thus, the CPU stay in the program loop until the input output unit indicates that it is ready for data transfer. This is a time consuming process and the CPU time is wasted a lot in keeping an eye to the execution of the program. To remove this problem, an interrupt facility and a special commands are used. Next is interrupt initiate input output. In this method, an interrupt facility and interrupt command is used to inform the device about the start and end of the transfer. In this meantime, the CPU executes other programs. When the interface determines that the device is ready for data transfer, it generates an interrupt request and send to the computer. When the CPU receives such a signal, it temporarily stops the execution of the program and branches to a service program to process the input-output transfer, and after completing, it returns back to the task when it was originally performing. In this type of input-output, computer does not check the flag. It continues to perform its task. Whenever any device wants the attention, it sends the interrupt signal to the CPU. CPU then diverts from what it was doing, store the return address from program counter and branch to the address of the subroutine. There are two ways of choosing the branch address. First is vector interrupt and second is non-vector interrupt. In vector interrupt, the source that interrupt the CPU provides the branch information. This information is called interrupt vectored. In non-vectored interrupt, the branch address is assigned to the fixed address in the memory. I hope you understand the topic of mode of data transfer. Like, share and subscribe Tecnia TV. Thank you so much.